Hello and welcome to your Experiment 2 post-practical lecture. So as always, let's quickly look at the outline for your Experiment 2 assignment. Again, it's split into two parts. So the first part being the report writing, and the second part being experimental questions, balanced equally, both being 50 marks. And the report writing this time focuses on aim, introduction, and background and references. And of course, the experimental question is dictated on specific points for the experimental section. So we'll first focus on this report writing part, and then I'm going to give you some specific hints or discuss some specific points for the experimental questions. So firstly, on the introduction, aim, and background. Now, you can split this into two headings, so introduction and background. So, have a first heading introduction, a second heading background, or you can just have one heading introduction and underneath that have background, or just have a heading introduction and sort of discuss the background in there. That's completely fine. Of course, the aims never has its own heading. It's always just essentially the first paragraph states the aims of the experiment. So that one does not have its own heading. It's just the background and the introduction that you can play around with however you feel like. That's your own creative input. So like I said, you usually start with stating the aim, but you do not say the aim of the experiment. Well, be creative in how you explain what you're going to do. In this study, we will investigate, or you start with something like isomerization forms a fundamental part of inorganic chemistry and provides the first goal of this study. It's just a creative way to say the aim of this experiment was. I mean, reading the aim of this experiment was such a grade 2 kind of way of saying things. So be creative, try to spread your academic wings a bit more. And like I say, the aim must still be concise, describe the output of what we are trying to study here quite well. So essentially, what is your introduction going to look like? So let's say you're going to put everything under one section. So just one heading, introduction. I think the first paragraph should always start with your aim. It starts with what you're going to study, and then remember the background starts to elaborate on the necessary theory and what has been done, why is this important, why is this necessary to study, what is the importance of the study, etc. And it's about 5 paragraphs, a page to a page and a half, depending on how large the study is. So that's your guideline. If it's 2 headings, then the introduction, I would say, is about 3 paragraphs, background, introduction is about 2 paragraphs, background about 3 paragraphs, give or take. I'll spend some time now on what I want specifically, some points I want you to discuss, but in a general context, this is what it is. So not too excessive for your ends, but yeah. So choose from the beginning whether or not you want to make it one heading, or you want to split it into 2 headings, or you want to make it a heading with a subheading. Okay. So once you've figured out what you want to do with the headings, then okay, under the background, so introduction discusses the aims and where we're going, why we're going there, right? And the background always discusses some relevant theory to the study. So it's sort of, and the importance. So, the background to the study. So essentially, the textbook that you need to read. So anything that you need to read up on to understand the results and discussion, even though you're not really writing the results and discussion for this experiment, you can include here. So some good ideas that you need to cover are Guggenheim's method, the importance of kinetics, importance of isomerism. Essentially, what are these things as well? So don't just say kinetics, what is kinetics, isomerism, shortly discuss, what cis and trans octahedral isomers are, how can you identify them, etc. And then I would like you to add about 2 more points to these. So discuss these and add about 2 of your own points would be good for you to have extra. Yeah, also discuss important aspects of the experiment in context of the experiment. So why is this background specifically important? So how does it now relate to the experiment? This is an important part. So in other words, why are you discussing Guggenheim's method? It's because we're going to use it and we have a situation where we have two isomers absorbing at the same wavelength, and hence we need to use Guggenheim's method. Or isomerism, why is it important? Okay, we're looking at 2 different isomers and they have applications in XYZ and whatever. You know, that's why it's important. Yeah, some general ideas. Remember, isomerism, the cool thing about it is, you know, isomerism properties, one thing can cure cancer and the other thing can cause blindness. It's always very interesting for me how that works. But okay, that's just on the point of that. So elaborate on the theory and then connect it onto why it is important. That's always the base thing. So have the reader understand what is it, why are you focusing on this, and what is it important later? Why do they need to understand it now? And a good idea is always like what is discussed in the practical guide, but don't just copy the practical guide. I mean, that is already there. We know what's in the practical guide. I've written the practical guide, so I know extensively what is in there. So don't just copy the equation or anything from there. Like build upon it, go into more detail. You can use it as a guide or as ideas, but don't just copy from there. Okay, so decide what you want your structure as, and then have 5 points on which you're going to build your paragraphs. And like I said 5 paragraphs. I mean, it's not a set in stone thing. It can be 10, it can be 6, it can be 7.5, for what I care. The point is, it's just a general guide. So no more than 2 pages, preferably. That would be more than enough. But of course, like if you go to 2.5, that's also perfectly fine. Like just don't go to 20. Like that's all I'm trying to say. Okay, so let's move to the assignment questions. Then the specific questions. Question 1 and 2, really easy. Some first year work for you to recover or to cover again. Should be okay. Question 3. Just because I know it sort of falls in between during the time that you learn about complexes and you're not that adept yet at everything that you need to be. I want to look at how to draw these structures and just looking at the charges and what everything means, etc. So if we look at the Ml3 complex, so that's the tris chromium complex from synthesis 2.1.1. This is how you need to draw the line structures. So in other words, you have the thick bonds coming out of the plane, the dash bonds going back, and you have the lines, just your axial bonds are always like that. So you can always start with something like that, right? And essentially here, you always just need to be cognizant of these charges. So aqua ligands don't have a charge, but your oxalato ligands, all the oxygens have a minus charge. So this has a minus, this has a minus, this has a minus, 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 right? So those are 6 minuses. Chromium is in the 3+ oxidative state. And that's where we get this 3- from. And that 3- indicates that there's 3 potassium plus ions that counter that minus. That's why this is called a counter ion. And that means this entire crystal species is neutral. So that's why there's a charge of 0 over there. Okay, very, very ugly drawn 0, but okay. That's where there's no charge over there. Okay, and that's what I want from you when you're drawing your crystal structures. And you can use Reaxys to draw these structures. You can also use all sorts of drawing software, ChemSketch, to draw these structures. Or if you really, 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 really need to draw them by hand, then you may. But just know that I will pity you because you are then illiterate in terms of your skills. So anyway, right. So that is this point. So that's how you need to draw these. Remember, and then of course when the aqua ligands come in, you just have like 2 of these, and you have, for example, the aqua ligands either cis or aqua ligands will be trans to one another. And you just substitute and draw in the oxalato ligands differently, and then of course this charge changes and the number of potassium ions changes. That's the molecular formula. This is the structural formula. The structural formula, yeah. This is the structure. This is the structural formula because this contains the counter ion. Okay. Just another point on specifically the ML3 complex. Remember, there's a question that asks about its optical or geometrical isomer. I'm going to give you a hint. Draw its mirror image. So in other words, take the mirror image of this and draw that. Should give you the isomer. And when I say mirror image, then something should ring about like what kind of isomer it is, because I mean the mirror has to do with some sort of optic capacity that we need to use. So anyway, cool. That is all I want to say about question 3. Then question 5 and 6 again are easy things to do. And question 7, we will mark with any mistakes that you make from question 6. So whatever you identify, we will continue on with and make the best for you because we aim to please at UP. And like I say, please ensure that you plot the relevant graphs. There are about 6. So remember all those graphs that I plot in the pre-practical lecture. You can plot any one of those to show and explain and discuss and to go into lengths. I think a lot of you will enjoy having some physical chemistry here because it's the most pure chemistry. It's nice to every now and again have some physical chemistry again. Essentially, the most important graph is that of equation 218. So that's the line of base, or the straight line, the one where you get k from, the rate constant from. That's the most important graph, and it should be somewhere. So that should be one of your 6 graphs. And also, I want to ask you want to give you a hint towards where the best comparative data will be found time-wise. Because you should see where should you see the best separation between the old and the fresh isomerization? So between the first like 0 and 600 seconds of the measurement, or will you see it later on? So remember, we're looking at the difference, and the old or the fresh isomerization is going to tend towards the old isomerization. So where is the best place to look at the isomerization kinetics? Is it at the beginning, or is it at the end? And remember, I said this time is it's technically irrelevant. You can look at time at any point. So you can break up these graphs if you would like and look at specific times. That's okay. That's up to you. It's an open-ended answer, there's a lot of, the memorandum is like 20 pages long. So you need to show that you understand more than you're able to get the right answer. Okay, that's a big hint. So I'm interested in your understanding here more than I'm interested in you getting just the answer. Okay, so that's my final resting words on this practical. Other than that, I think this should be a nice prac. Should be an easy one. It's your first synthesis of complexes. Should be cool. You should enjoy the colors. Yeah, I wish you the best of luck, and may the odds be ever in your favor.